There's some pizzas at the back. Please have a seat. Okay, I can start. Started already. Okay, guys, welcome to JS Wednesday, September edition. And I guess I took a gamble and picked the Wednesday after the long weekend. Maybe it wasn't a good idea, but anyway, I hope you guys enjoy. Thank you for being here. We have this recorded, so you people who are not here watching online, you can watch later. So pizzas. Oh, before pizzas. Okay, this awesome space is Collabs, and Collabs is a co-working space. They just opened here 2 months ago, or less than 2 months ago. Definitely tell your friends about this space and fill this space up. Okay, pizzas was sponsored by CoinGecko, where I work. So the shout out is we have an API where you can get all the coin data. Let's just try. This is Swagger. Alright, that was a bit slow. I think because you can provide a filter list. But yeah, coin data, coin pricing, charts. Feel free to hack away using our data. It's completely free, but with no guarantees, no SLA uptime guarantees, because it's free. All right. And so we actually have some widgets. If you have a webmaster of some, you're a webmaster of some websites, and you want to have some crypto sidebar, you can come to our widgets page and just grab a widget. We have a coin chart, we have a marquee, you can put it at the top, or some static headline widget. So this is all built using our API as well. And also the shout out that we have a open source library called Crypto Format, because a lot of coins are quite worthless. They need more decimal places. So for example, CoinGecko.com uses Crypto Format to display more decimal points for some values. If it's even smaller, up to 8 decimal points. If we remove these decimal points, we get a ton of support emails. So Crypto Format helps you to what are you doing, Wig? Crypto Format helps you to format your crypto values. Okay, so that's it for sponsor shout out. Next, I'll pass it on to Jesslyn, who will be talking about Angular and building a PWA with Angular. And she loves Angular, she's pro Angular, so let's listen and open our minds a bit. Welcome, Jesslyn.
What the heck, you open mind a bit.
You know, people are very opinionated around here.
Hey. Oh, I haven't shared my screen yet. Wait. Okay, so today I will share about Angular and PWA. I actually set an alarm for 30 minutes. So if I exceed, it will just ring. Okay, so a little bit about myself. My name is Jesslyn. I'm currently a software architect at Randstad. So Randstad is a company that do all sort of HR activities like hiring, headhunting, contracting and stuff. And I'm also a GDE for web technologies and Angular. Okay, so today I will talk about PWA, roughly about what is PWA, and how to use Angular with PWA, like how to start, how does it work, and how to make it progressive. Alright, PWA. So let's do a test. Let's do a quiz together. So we call it Fakta. So Fakta Auta is actually Malay. So it's basically a facts or fictions. So I will list out a few questions. So you just tell me whether it's a fact or it's a fiction. Okay. So PWA is just a normal website. Facts or fiction? Fact. Yes, it's facta. Yes, it's fact. Because PWA basically is a web, and it can talk to your phone native API, your mobile phone native API, for example, camera, sensor, or spawn notifications. Facts or fiction? Facts, okay. It can work offline or semi-offline. Facts, okay. It's installable, it can be added to your home screen. Facts. It is fast and its performance. Yes, okay, it actually depends. It's not necessarily fast. Normally when you hear about PWA talk, people will say PWA is fast. It's actually fast, but you know, as a developer, we can always do something that make our web like slow like hell. So it depends on how we do that. And it can work cross-platform plus cross-browser. So yeah, so it works cross-platform definitely because we have browser. So as long as you can open the browser, you can open the website because it's just a normal website. But whether it's work cross-browser or not, it's not. Like the older browser is not supported, or even the modern browser, some have pretty good support like Chrome, but there are some still in the implementation, although there are some features already support like Apple, what is the Apple browser again? Safari, yeah. Yeah, Safari. So you can install updates on the fly, or just refresh the browser, you can install it. So fact or fictions? Yeah, it's a fact.
But you don't want to install them.
Pardon?
Some PWA experiences I find quite jarring. It asks you, like, click a button to update or something.
Yes.
I mean, that blows my mind because the web doesn't need to do that.
Yes. Yeah. There's two ways to do it. Either you can force a reload, or because when you have already loaded the page, but there are some updates like you push a new file in the server. If your page detected there's a new file, sometimes what people will do is that it will just show a bar, ask you to refresh the browser, or some people will do just a forced refresh, or they don't tell you anything because the update is not that significant. They will just wait for your next refresh. So it depends on.
You understand what I'm trying to say? It does seem like a step backwards.
Yeah. Yeah. Okay. Is safe? Right? Yeah, so it also depends because for PWA, one of the features they are saying is safe because it's all PWA need to be in HTTPS, so it's safer than HTTP. But whether it's safe or not still depends on how we develop the website. Okay, so basically we'll go through like what is PWA by answering all these questions. Okay. Okay, so one of the biggest myths about PWA, I feel, is people think that it's all about adding to home screen. There are people that think, oh, PWA means adding to home screen. It's actually not true because PWA means progressive web app, so it can be progressive web without the apps. What the most important thing is bringing better web experience to the user, make it fast, make it safe. So it's not necessarily add to your home screen, but basically it means that you bring a better web experience to your user. Okay, so now let's talk about Angular and PWA. I guess how many people here dislike Angular? Or not pro Angular? Okay, so not pro Angular. So because I roughly know that KLJS is a little bit not pro Angular, so what I will do is I will just tell you like how do you set up an Angular project, and then how do you add in PWA support. Okay? I try, okay? So to create an Angular project, basically you don't need to start it yourself. You can use CLI. I think now all of the framework have CLI, like Vue have CLI, React have CLI, Angular have as well. So what you need to do is you do an npm install the Angular CLI. After that, you get a command called ng. If you want to create a new project, you just run ng new and then pass in your project name. After that, actually, you can put in more and more configurations, but this depends on you. The most basic command is ng new my app name, then it will tell you that it will create all this sort of file. Some people will feel that it's a little bit scary because if you use Vue.js, probably I think 3 or 4 files get created, or React create React CLI, probably also a few files created, but with Angular, you get all these files. So some people will get a little bit scary, like why do I get so many files? But you don't need to know all these files. You just need to know how to get started, okay? So basically, this is how you create a project, and all these files we created for you. After that, to make it PWA, to make it as an PWA, to add the PWA features, you just run ng add alias angular / PWA. Then you get the basic, very basic PWA support in your Angular applications. Then you just build it. It will generate a set of files for you to deploy to the server. Then you just deploy it to your server anywhere, the whole folder. Then you get the applications. Okay. So after I running these 4 steps, npm install CLI, ng new, and ng add, and build and deployed it, what I will get is, so I already deployed it to URL called Potaro, okay? So what basically you get is this. You see a very basic page that tells you that welcome to the app. So this is all default Angular code. So what you can see is, so in the network, let me show you the network tab. So basically when you first load it, you see that you see the size, which means it's fetching from the from your network, from the server. If you refresh the second time, you can see that all this file is fetching from service worker, which means Angular already added the basics service worker, the PWA features for you, because it's fetching from service worker. So if I switch it to offline, it should still work. Yeah, it will tell you that some file cannot fetch, but for those files that's fetched from the service worker, it will still work. Okay, so this is how easy it is to create a PWA, but there's more, because we will unpack all this. Okay, so okay, let's say in a mobile view, because just now I'm showing from my desktop. Let's say in a mobile view, so this is what you get. So when you call this potaro.com in your phone, basically you get this banner asking you that whether you want to add to home screen or not. So if you want, when you click it, then you just add to your home screen. Of course, you can disable this add to home screen features, because I'm saying that PWA is not necessarily add to home screen. There's a way for you to disable that, but you still have the service worker in your apps, just that you don't have the add to home screen features. You can disable that. Okay. So like, actually how does it work? Like after you just running the 4 commands, you create everything. Of course, this is not magic. So when you run ng add alias angular / PWA, okay, before that, a minimum PWA, you need a manifest.json file, and you need to register a service worker. This is the minimum PWA requirement. So after you run the ng add command, right, behind the scenes, Angular actually create a manifest.json file for you, which is one of the basic requirement, and it's create a set of icon for you. So remember, every time when you open up an application or anything, it will show a splash screen. So the splash screen has some icon. So Angular creates a set of icon for you for that logo. And it's help you to register a service worker. It's create something called ng-sw-config.json. So guess what is ng-sw? Config is configuration, right? ng is Angular service worker configuration.json file. Later we will see like what is it inside here. Okay, so this is the so I just show you the command here. So when you run ng add angular PWA, it will tell you exactly what file is creating. So this is, it tells you that it creates the ng-sw config and the icons file. Angular is update the Angular, what file that is updated. It's very clear that it tells you what is it doing. Okay, so this one no need. Okay, so in summary, just now we say already, like the second time when we load is called from the service worker. So what is service worker? So service worker is the middleman between you and your server, between the apps and the server. Okay, so let's say this is your browser, this is your app, this is the this is your server. So normally when you request anything, you will just directly request from the server. But with service worker is like a middleman that you can configure. So for example, you can say that you can ask service worker to cache a certain file. then when the apps request from the server again, if the service worker have the file, it will just intercept and return the file. Then you don't call, you don't issue a call to the server. Okay, depends on how you configure that. Okay, so service worker support. So currently, most of the modern browsers support service worker. Don't expect Internet IE6 support that, no. But all the modern browser actually support service worker and Cache API, mobile as well, desktop as well. Okay. In fact, for Windows, you can actually install a PWA in your. You can search PWA from your Windows Store and then install it. This is what Microsoft is working on. Chrome is also working on PWA from desktop. Yeah. Yes.
What's that icon in the middle? What's that browser in the middle?
This is the very famous browser which I rarely use. Samsung browser. It's actually the usage is actually pretty high for Samsung. Yeah. Okay. Yeah. Okay. Okay. So let me show you the ng-sw config file, how it looks like. So it's actually an object with just two properties for now. One is called asset groups, one is called data groups. So the asset groups is an array, data group also is an array. So for asset group, it's actually let me show you the asset groups. So this is basically one of the asset group setup. So for the asset group, you can give it any name. You can create an object, call it any name. For example, I have a name called apps, and you specify the install mode, whether you want it to prefetch or want it to be lazy. And what are the resources that under this resource group? You can mention that these are the file group, the patterns that you want to cache it. So I want all these files like favicon, index, HTML, all the CSS and all the JavaScript file to be prefetched from service worker. So basically this is how I configured it. So if I have another set of files which I need a different configuration, different install mode, I can just add it because it's an array. Okay, so this is how you configure your asset group. The second one is data group. So data is like your API. So you have a lot of API call. For example, for some APIs, you want to cache like 10 data from the APIs. So you can specify that. So for the data group, the object is slightly different. You have properties called URL. In the URL, you can put in your URL patterns, like what are the URL that you want to cache, and what is your cache configuration? What is your strategy? Do you want it to be performance or do you want it to be freshness? So performance, which means if I can find it in the cache, I will just take the cache. If it's freshness, I will always get it from the network. And what is the max size that you want to cache? 100, and how long do you want to cache? Like 1 year or how many days? Okay, so basically you can configure that, and you can have multiple configurations. You can have another set which have different caching strategy. Okay.
So this overrides any caching with normal URL or something?
Yes. Yes. In your application.
So I was just thinking to myself, what does this do that the normal cache control?
You mean the normal browser cache?
Yeah.
Because by default, service worker doesn't do anything until you instruct it to cache something. Yeah.
Like, you know, in HTTP headers, you can instruct like an image to be cached, right?
No. Yeah. Because like on the normal cache that we have is actually the browser cache. So the browser will sometimes cache the request. If you request too frequent, then it will cache it. But browser cache is something that you cannot control. But using service worker is the cache that you can control. Yeah. Okay. So that's basically how you configured it. So after you configure it, right? Just want to show you the code. Can you still see the screen? So after you configured it, when you build it, right? What it will do is it will generate a field file. It will generate all the JavaScript file that are necessary for your application to start. But it's also generate a file called you can see that it will generate a file called ng-sw.json file. What this file does is, based on my configuration, it will generate the final URL that's supposed to be cached. So for example, just now, my configuration, if you remember, let me open back. For the assets group, I just say that all the CSS file and all the JS file. So after you run the build, right, after we have the files, what Angular generate for us is the final file, all the JS file, the final patterns, and the HTML final patterns. And for all the assets, I actually configure for my assets, I want it to be lazy load for all the images. So it will generate all the final setting for me, and it generate a hash table so that we know that whether it's a fresh, is the latest or not. And there is a bunch of things for us. So just by using the configurations, okay?
So this example, will you be sending these icons to the browser, or?
Okay, so for this example, right, so let me show you this, because this is a default project, so let me just show you the ng-sw-config after you just run the ng-add pwa in your application. So for this one, I actually have two settings on it. I have the apps, I have only assets group setting, I have the apps, which is the prefetch mode for all the HTML, CSS, and JS file. But for the all the things in assets folder, I want it to be lazy loaded, because all the things in assets folder, which means my icon, I don't want it to cache it, or I don't want it to prefetch it and cache it, because for icon it's like only when I request I want it to be cached. If I don't request it, means I don't need the icon. Make sense? So we don't fetch it.
So this means you tell the browser you only select what you you're not pushing it.
Yes, I'm not pushing because it's lazy. Because the mode is lazy, which means it won't push it. It will just when I go to a page, I request for a certain asset. But once I request it, it will cache it. If I don't request it, it won't cache. Okay?
I guess my real question was, does it need all those icons?
Yeah. So the icon, so in this example, the icon is actually for your splash screen. So for a splash screen, normally we have a set of different size of icon, because we have different size of phone. We have iPhone, which is very high definition, but we have some low-end phone. So we have a set of icon. Yeah. But in fact, normally in your assets folder, you have some other images, some other assets that used by your application. Okay, so basically that's it for the configurations. And so Angular has a concept called service. So if you work for Java or .NET, this is where you write your business logic. So Angular provides a way for you to write a business logic called a service. So by using this, Angular also provides you out of the box a service called SW update. So this is a service that allows you to check whether your apps have whether your service worker have any updates, you have any files update. So to use it, you just need to inject the service in your constructor, and then you just call updates the service.check for updates. So it will just try to go to the browser, go to your server, check the configuration file, whether the hash table, if there's any new files. So if there is, when you subscribe to it, you can do anything here. For example, like just now, he is saying that some people actually show up wherever there's a new file, they actually show up a bar call you to refresh it. So you can do that logic, you can write that logic here wherever there's an update, or you can force a reload, or you can not doing anything. Just let the user to wait for the next refresh. When user refresh the browser, they will get the latest update. Okay? Okay. So just now we talked about PWA in general, like add to home screen and some caching. Let's dive a little bit more on progressive. Like what does this mean by progressive? So this is the dictionary definitions. So progressive, which means change, improvement, making progress towards a better conditions. So you can see that with service worker, we actually try to cache the file for a better performance. Okay, depends on our configuration. But basically we make less requests to the server, which save the data and the response time is faster. So this is one step of progressive. But for Angular actually provide you some others features to make it more progressive. So for example, when you build the your application, you pass in a flag called -prod, which Angular will use something called ahead of time compilations to compile your code. Basically ahead of time, which means that it's a very optimized compilation. Besides doing your minifying your code, uglify your code, it's try to understand your code and try to do some compilation to make it run faster in your during the runtime. And it's also use build optimizer behind the scene. But what you need to do is you run and you build with this flag. And the other thing that Angular provide is lazy loading. You can do lazy loading. So for example, in your apps, you have 10 different URL, 10 different routes. So probably when the user access to a certain features, they only normally go to the 3 normal routes. For all the like settings features and all the other features which the user less likely to access, we just put it in lazy loader another route. Wherever the user don't go to that screen, we don't load all the JavaScript and the CSS of all those files. So this is something that we call lazy loading. So you split your code and try to lazy loading part by part, only when user requests it. Okay, so Angular by default support that, and also it's also support another mode called preload all modules. So what does preload all module means is that, so just now we talked about lazy loading, right? We already split that, right? But if it's PWA, you want the user, like for example, I go to a normal like the home screen, I would just load this route. Then, but once I finish loading this route, I want at the behind the scene, the service organization try to load all the files that the user haven't accessed yet. This is called preloading. I try to preload other modules. It's not until the user requests, then I request that. I can give an instruction to Angular to actually, when you're done loading your current module, try to preload some others module. So like this, you can do like the best of both worlds. Okay, and it's 100% flexibility, depends on your preloading strategy. You can write your own code to your own preloading strategy. Okay, so this is how so if you are not an Angular person, so this is just for a reference. So basically this is how we configure the route to be lazy loaded. So for example, I have a main route called customer. Under customer, I have customer details, customer add screen, customer delete, customer edit, or wherever screen. I just group all these under a module, and then I just said that I want to lazy load this whole thing. Only when the user go to any route under /customer, please load all this, the JavaScript and CSS file under this module. Okay, so basically this is how we configure that. Okay, so this is how we configure the preloading strategy. How do we configure the preload all modules? So if you are not an Angular person, so this thing might sound a little bit confusing, but it's actually, what we need to do is actually this line. The first line, the first 2 line and the end 2 line is already there. We just add in this line. Okay. So in Angular supports server-side rendering as well. So this is something that we call SSR. It's not the traditional SSR, which means like .NET or Java. The traditional SSR is everything is loaded from the server, but the modern SSR is basically for the first load, we load it from the server and compile it, your JavaScript all compiled, all rendering nicely, send it down to the client. But for the second times onward, when all your code is already in the client side, it will just do client side rendering. It's not going back to the server again. This is the modern SSR means. Okay, so in Angular actually support this SSR, or sometimes we call it universal rendering. So when you have no SSR, this is how the progress look like. You load the HTML fetch all the file from the server and load the HTML from the client side, and then we bootstrap it. Then the first meaningful pane happens after the bootstrap. But if you use SSR, basically you load the HTML, and then your first meaningful pane actually renders from the server. So it's happened much earlier. And then only you bootstrap the application in your client side. So this gives the user, the benefit for this is it gives the user better first load performance experience, because you can see that the first pane it's happened earlier. But after the first paint, basically everything is the same. Okay. It's also because it's the server-side rendering, which means you can configure your SEO and your social link from the server side. But this also comes with some trade-off, because it's a little bit more complicated if you want to do universal rendering or SSR with Angular. Actually, not just Angular, if you Vue or React.js, basically there's something that you need to take care of when you opt to do SSR. So you need to know that whether you really need this or not. Okay. But Angular gives you options to do this. So this is how to do it. So the long way is that you run a command called ng-generate universal and then pass in some command. And then I give you a guide, because the guide is actually quite long. So you need to follow the guide to run it. There's another short way, it's similar to the add Angular PWA. You just add ng toolkits universal. So this is someone else actually creating this whole thing to do all the adding files and changing, updating all the files. After that, you just run these two commands and you get your basic universal. But you still need to configure something for your own like SSR configurations. Okay. Okay. So this is the link that talk about this. All right. So hey, I'm on time. 34. Yes. Okay. So PWA, the PWA actually cover 10 characteristics. It needs to be progressive, like slowly enhancing, like lazy loading, service worker to cache the file. It needs to be responsive, which when the user open it in mobile, show it mobile view, not showing it like a desktop. Make it smaller. And it depends, sometimes it can be network independent, like for all the assets files or all the application JavaScript file or CSS file, it should be network independent. But if you need to call like the server to update some data, then it might not be. Depends on how you handle it. Like for example, Facebook is not PWA, although they are developing that. But Facebook, when you are doing apps, right, when you try to post a post and you're offline, it will tell you that it will post later. Actually, you can do something similar with your PWA. You just need to cache it first. When you detect that it's online, then you submit the request. So in that way, it's sort of network independent. And it needs to PWA should provide apps like experience, like add to home screen, and it's fresh, which means it's auto update, auto refresh when you open the apps again, and it's linkable because it's just an URL away. It's not like the traditional Android apps. You need to basically install that for all because it's just a normal website, so it's linkable and installable. Re-engageable, because for PWA, you can use web notification. You can use notification. Basically, you will just pop up the notification bar for your user to re-engage. Re-engage means I can click it back. You can notify the user, click it back, and re-engage with your apps again. And it's discoverable via your browser and your search engine like Google's or something. And it's safe. Like we say that's safe because it's HTTPS, but it depends on how we develop our apps as well. Okay, so Angular love PWA, and this is where you can get the slide. Thank you. Okay. Questions? Yes. Yes.
You mentioned SSR there. What was the relationship with SSR and PWA?
Because PWA, which means one of the PWA, which means its performance is fast. If you are doing server-side rendering, it's actually fast for the first pane, like I showed you just now. So it's actually one of the criteria for progressive, like make it fast. So basically, it's not like the PWA like installable that part, but it's basically the performance that part. Yeah. Yes. Okay, in my work currently, there's no point to do PWA. like for my current work, I don't do PWA, but I do make a PWA apps for the for one of the events that we had before, the IOX KL, the events. So it's an event management apps for all the volunteers, basically to check check in the audience and to basically check whether the audience pick up something or drop the lucky draw. We just want to track all the activities. For that, we use PWA because it's the fastest way to ask because all the volunteers have the phone, and then what they need to do is just open the URL. I don't need to publish to the App Store or just ask them to download APK or application to download it, but they just need to do that. And if for normal website, for apps like Twitter, Facebook, it actually makes sense to do PWA. Even I think for some government application, that's the thing I've quite fed up. Some government application like the car park or something, they just ask you to install an app in order to pay the car park. So this doesn't make sense for me because sometimes I just go to the car park station like once, then I need to install the app in order for me to pay that. So it doesn't make sense for me. So if they do PWA, so it can be a website, or I can just install it in my app to basically use this daily. I think it's better.
Isn't there a danger that the PWA seems so much more complex to get into as opposed to a standard website?
What do you mean by complicated? You mean?
When you're bootstrapping a project, it's like 1,000 million files for each things like that. It's quite complicated, right?
For yeah, this because for PWA, basically what the features that you add in basically is the caching part and the lazy loading part. So it's not that the lazy loading part, whether or not you are doing PWA, I encourage people to do lazy loading. But for the caching part, the service worker part, basically I don't think that is complicated, but you just need some knowledge to actually configure it. Basically, like, yeah, just one more thing, like for website like Google Maps or YouTube, they are running service worker behind the scenes. Just that they don't ask you to add to home screen, but they do have a service worker run behind the screen to actually cache some of the file. Okay, I think it's time for the next speaker.
Yes, I have to stop
so
everyone.
yeah, we can talk later. Okay, let us. Okay, do that.
So we are running a bit late. Next speaker will be Casey. He will be speaking very aptly on Angular state management. So by now, I think we are already partially convinced that Angular can help us bootstrap our application very quickly. So now Casey will tell us how to manage state in Angular.
Oh boy. Okay. Can see? Cool. Okay, hi. Thanks for coming, guys. So my name is Casey. I'm a software developer, independent software developer. So I actually started this thinking about doing this talk after picking up an Angular library called NGXS because I think it's pretty cool. But as I was actually doing this slide, I realized that there's really two concepts that I really wanted to share with you guys. So it's technically not just about NGXS. So if you're not a fan of Angular, don't worry. Hopefully this talk you can actually go away with two concepts in mind. One, how to think about reactive development. Second, how to think about handling state in a somewhat larger applications generally. So more of a concept rather than coding, although I'll be showing you guys some code and demo. Okay, so you can get the slides here. So all right, so first thing is when we talk about reactive development, we actually talk about observables, RxJS, and certain things, right? So why these observables? Because that was not part of my plan, but I don't think we can do an effective discussion about NGXX or state management without talking about observables, especially in the context in which we use this. So really think about observables as JavaScript's asynchronous way of programming, right? So traditionally, you might be familiar with things like callbacks, functions, setting timeouts, set some intervals, and then get a callback, do something. That is asynchronous programming. But those are very primitive way of doing it. And if you have managed or created applications like this before in the past, once you go beyond 3 to 5, 5 to 10 set timeouts, you'll realize that your app is out of control. So it doesn't scale. We also have things like promises, async await, which also solve similar problems, right? So they work, they're excellent, but observables is similar in that sense. But it also lets you do certain things. Like what? I think that you can do reactive programming better with things like observables compared to some of the other programming constructs that I mentioned earlier, because of what I'll show you in a while. But before we get into the demo, just some quick concepts, right? So how to think about observables. Observables basically think of it as like a stream of values that will come to you over time. It's similar to like setting intervals. You set interval 1 second, and then every 1 second you get some data, right? So observables are the same concept, right? So you just get a stream of values. The difference is that you can actually do stuff in between. Whenever you get a value, you don't just get a value and then immediately deal with it at the end. What you can do is like similar to how you're using bash command line and so on. You can do piping. So you can pipe it and then pipe it to do something else, pipe it to multicast it to something else, or take a lot of values, wait for a lot of values to come in, and then turn it into something, one single value, and then do something after that. So it's very flexible. So if you think about real world scenarios, right, most of the time it's quite complex. You wait for a lot of things back from, you want to perform an action, you need to make a couple of service calls. When all these service calls are back, then you do something, right? So that is what observables are good for when you do piping, right? So concept. So end of the day, basically all these values that gets emitted after you do your operators and all those things, you basically emit a value or multiple values to your app, and then you deal with it. That's the concept. And you deal with this concept, you deal with these values by subscribing to an observable. It's a slightly different concept, right? But that's how it works. Another way to think about observables, because I realize that even for myself and a lot of people, when they first get into the idea of observables and RxJS, it's very confusing. What the hell is happening? I create observables, nothing run, and all those kind of stuff, right? One way to maybe help is to say that, think of it as like a collection, right? Java collections or whatever collections. A collection is something that you can iterate through, right? And you iterate through a collection by calling next. So you have a collection of like 5 items, next you get 1 item, next you get 1 item, next you get 1 item. So instead of that kind of concept, think of it as collection where you don't call the next. You just write functions that will run when next happens. When next will happen is not determined by your code. It's determined by the external event or factor. That's it, right? So essentially, I think observables, you can think of it that way. So with that in mind, maybe we can look at a simple demo first, right? So simple asynchronous operations. So as I mentioned, all these are asynchronous programming concepts in JavaScript. You can do all this with whichever one that you choose to. So in this demo, I'm going to show us running, print running something on the screen. Wait for 2 seconds and then print done. Wait for 2 seconds and then change the message to uppercase, right? So, okay. So it's going to be pretty fast. So you, so you got to look here, right? So you can see that thing blink. You can see this thing. So I'll just reload. You see it's like it says running, and then it gets done, and then after a while you get done in caps, right? So how does it work? Let's take a quick look in all the different programming constructs, right? So if you look at as a promise, it's pretty simple. You do a new promise, and then you say, oh, I set a promise value, right? And then I set a timeout for 2 seconds, and then I say resolve the value is done. And then you do a then, and then you wait, you set another value, and then you set a new promise, and wait for another 2 seconds, and then you set the value again. And when you resolve the second time, you turn it into uppercase. So that's how you get it done in promise, right? You can do the same thing in observables. Actually, it gets more complicated because, so from this simple example itself, you know that if you're trying to do something simple, don't use stuff like this. Just you know, new promise, then do something. But this is just for demonstration purpose, right? So if you want to do it as an observable style, so remember I mentioned it's basically a stream of values coming in. So we start off and saying that off means given this observable is running this value, this is a value, I pipe it through a series of operators. The first operator that I pipe it through, I just call it a tab, and then I'll just set this observable value to, you know, that value. So basically it will update the screen. After that I delay, I just wait for 2 seconds, and then after that I just perform some kind of async operation, meaning this async operation can be like going to somewhere and grab some data back, and then I resolve another value. The reason why I use a concat map here is just to demonstrate that we have actually quite a number of different operators, and that is one of the confusing part about RxJS if you're new to it. But just bear in mind just bear with me. We'll figure out some of these things in time. All right. So in the second step, after I wait for 2 seconds, I actually intentionally did a promise resolve and say that observable is done. What this means is that this part shows that observables can actually interop with promises, and it doesn't really wait, it just does an async operation and return you the value. So once I resolve, what happens here is that this item number 5, the tab, the value here would actually be observable is done. So what I'm doing then is basically saying that, hey, this dot observable value equals to the value, which is the value that was passed down, that has been piped down. So I update the UI with this, and then I wait for another 2 seconds, and then I subscribe. Remember I said you have to subscribe to an observable before something runs. So once you subscribe, you then say, okay, I update the observable value. This observable value is something that I actually render on the screen, right? So it's the same thing. So you basically say value to uppercase, and then it will update. What I'm demonstrating here is basically the gist of the observable chain, not the rest of the Angular code or whatever, because technically it doesn't matter. We are talking about observable and RxJS here. It does the same thing as the previous example. I understand it is extremely complicated to do something like the first example, but that's how it works. So then why do we use it? We use it because a lot of times the async operations that we need are not as simple as what you have seen in the first example. A typical one, for example, something like this, not so simple asynchronous operations. I would hate to be doing something like this using promises or even async await, I'm not sure. But if we are doing it with observables, I think it's manageable. So how does it work? In the example, we are basically, say for example, we are given a username on GitHub. I want to make a REST call to get the list of followers. So the list of followers is a little bit small, but basically the list of followers will return me an array, where within the array I will have the login name of the users that's following you. And then for each of this follower, I want to perform another async operation to then a REST call to GitHub to get the number of followers this person has, right? So it then returns me that value. What I want to do is, until I gather all the total count of all the followers, add those number up, and then emit that value as something that my application will make use of, right? And something to take note here is that when once I make a first call, the subsequent calls, maybe let's say I have 10 followers, I can concurrently go out and grab all 10 at once, or I can say I want to grab at most 3 at a time, and then grab all 10 when you're done, and then count all the total values. So an example of this would be something like this. So count follower of followers, I click on, we can do this. So it's a bit fast, I don't know, we'll see. It's too fast. So it's like, basically what it's doing is that first it gets this, right? And then concurrently it gets the subsequent tree. So how does the code look like for something like that, right? Sorry. Let's look at the gist of the code, right? It's actually pretty long, I must say. But if you look at the real code, it actually speaks quite nicely. It flows. Unlike the other async constructs in JavaScript, I think once you're familiarized with the approach, it is actually quite easy to follow, right? So let's try. First, I update the message that says fetching the follower list. So basically this updates the UI, right? So not important. What I'm saying is that from what? From fetching this particular URL. So this part itself is basically an async operation already. So I am saying that please go fetch this thing. Once you're done fetching this thing, I basically get the response. If you're familiar with the fetch API, it basically returns you a promise. So meaning you have to then new promise then something, right? So instead of doing that, we basically do a concat, and then I just say response get the JSON data, and that's the output. And then so basically what this means is that I now have the JSON data resolved after the promise, right? So then I'll concat the values. So this JSON of each of the value within, because this JSON response is an array, right? So I will be saying that the dot, what do you call that? You spread, yep. So you do a spread on this JSON, and then you get each of this individually. So for each of this guy, I pipe it, and then I take up to a maximum of how many followers. The reason for this is that in this demo, regardless of how many followers you have, we only look for the first three, because there is a API rate limit call on GitHub. So I just limited to 3, otherwise you get errors. Right? So we get the top 3, and then now for each of this follower, you get his or her follower by calling a merge map operator again. So this operator basically says, hey, again, go and fetch this guy out. Given this user, fetch the user's login. The user login basically is the username, right? So, and I do this concurrently up to 3 concurrent calls at a time. So this part will complete, so it will basically do this call. Once this thing is done, I will then get a response again. It's similar to the top example. And then I'll do a tab, and I'll say who I've received. And then I will extract the follower counts, doing a map, get the followers. And then this toArray basically does the opposite of the merge map. So the merge map basically says I go out from from the list of my followers. Each of this guy, you go out and make a REST call. What this toArray will do is that for all those calls, combine all of them into a single array, because each of the response of my follower, I have extracted the follower count, right? Here, the follower count. Combine all those follower counts as a single array. So what that means is that at this stage, after this stage, there will only be one value that will be returned, which is an array of all my followers. So what I'll do then is that, given all my followers, you reduce it. So this is basically your usual map reduce JavaScript array thing. So you basically do a reduce of the follower count. Basically, you're adding them, all of them up. So what happens is the value the value after this map will basically be the sum, right? So all I'm doing now is that I subscribe to the follower count and I update. You see? So yes, it might look very strange, very like, what the heck are all these operators and all those things? But if you think about it, I mean, if you look at the code, it actually speaks quite nicely. It flows. So that is really the benefit of doing something in RxJS or observable styles. You pipe everything together, and then you figure out what you want, transform, do all this funny stuff. End of the day, you get the values that you want. That's the concept of RxJS. And this is a single example, somewhat complex, but what I feel is that, what I believe what you guys can see is that a lot of websites nowadays, modern websites, a lot of things are happening, right? You load a page and then things pop and move around. Behind the scenes, a lot of asynchronous operations are happening. So the way to do reactive programming is to construct and manage your RxJS observable stuff nicely, and then update values. That's basically it, right? So hopefully this makes sense. So that is observables. Next stage, next part, I want to talk about state management in Angular. So why do I talk about the 3 common ways? Because there are actually options, right? So Angular is quite nice in the sense that it actually covers a lot of the, how do you say? It provides a lot of things out of the box, right? Even state management is technically provided out of the box if you want, right? So depending on what kind of apps you're developing. So in this case, I would say that there's actually three types of common ways to manage states. The first one is using components with services, and we'll just go to the next one. Okay, so component with services, right? So it's the most simple approach. That's how Angular does things. Angular, for those who's from Java programming or has not done Angular before, the way I tend to explain what Angular is to other developers, especially if they know Java, is that Angular is basically Java with Spring Framework punya dependency injection built in, right? So that's what it is. You can literally, when a Java developer looks at Angular code, it actually feels like Java. And I think the learning curve really reduces a lot, which is probably also why a lot of non-Java developers may not fancy that lah. So it's a preference, right? But you basically can inject services or basically classes or services into components, and basically with that, then your state is basically managed by within your component itself or by the services that you inject into the component. So the benefit of it is really easy to get started. Is how Angular works. The con of it is that if you are developing very complex, sorry, let me rephrase this. The con is that if you do have a relatively complex or complicated application, the components tend to be very complicated because you're putting everything in this component itself. Maybe you do externalize certain things into the services, but still your component tends to have to deal with a lot of stuff, interacting with the different services that you have and so on. So it gets complicated. The other downside of this probably is that you may end up with some or a lot of duplication of state, especially when the when your application grows, and also especially when you have more than one developer involved in the project. Then everybody will do their own style, and every component will have a different style, and then everybody keep their own state. Because my state is better than yours, so I keep it in my component, you keep it in your component. As the application scales, you'll realize that you have state all over the place and they're all stale. So problems, bugs will come, right? So that's component with states, services. A slightly more evolved version of the first example is that we have presentational versus smart component style. So it's the services, everything is still there, right? You still have the same things. The slight difference is that Angular has this thing called okay, so okay, so basically it's separating the states into different types of components. You're separating into a type of components where you need to manage state, and the other type where you don't need to manage state, right? So if you're familiar with React and you do things like Redux and so on, presentation component is basically stateless functional components, while smart component is basically your container components. Those that you connect with Redux, that is your smart component. So you have the same concept in Angular, right? So presentational components basically use input and output annotations to pass data around, and it doesn't really access, or you probably should not be injecting services. That's the concept, right? So it doesn't stop you, but you should not do it, right? The rest I think I will not so important for now. The pro is that doing this, it actually separates your presentational components from those that manage the business services, right? Or yeah, the business services. So what this allows you to do is that have certain developers create presentational UI or the screens without touching or dealing with all the backend services. That's the benefit. The downside is that you still have services within your smart components, and you don't really get reactivity for free. Meaning, it's not that you cannot, but the reactiveness is something that you have to intentionally put in. So it depends on the discipline and the capability or knowledge of the developers involved. So chances are, as you scale, you have different qualities. Some put it in correctly, some put it in incorrectly, some don't put it in. So that's the downside of it. So the final state management style, which is really what NGXS is about, is something called CQRS. It stands for that. It's basically a pattern that is popularized by Redux or Flux or whatever in the React community. So if you're familiar with Redux, this is what it is, right? So in Angular world, there is already a sort of like de facto standard or library to do or to achieve something like this. It's called NGRX, but I'm not talking about NGRX today. We are talking about, I'm trying to share something on NGXS. And it is really a very new library, but I think it's very awesome. All right, so let's take a look at what it is. I'll skip this. I'll just run straight into the concept. So the concept, basically, you're looking at the CQRS concept, right? Is basically you have some components that dispatch actions. Actions will do like some processing, connect to your backend services or whatever if you need, and then update some state into your store. So the component is only responsible for dispatching actions, and the component is only getting data from your store. End of story. It's a very simple concept. It actually works this way when you program it, which is why using things like CQRS and Redux and so on, it's actually, people say it's very simple, but those who's new to it find that, oh, why do I need to do so many things? The value in doing this kind of stuff is not because you code very little, but because the concept is so simple, you can scale it very, very widely with a lot of people, and everybody will do it in a very consistent way. That is the real value, at least to me, right? So, I think I mentioned this. So component selects data from the store to display. So component select data from the store to display. Component dispatch actions with payload, meaning it's like I want to take an action. So I say I want to add a new book. So I will create an action that says add a book. My payload is basically which book I want to add. So that's the concept, right? So actions, we create actions to actually do the work, mutate or basically make changes to the application state. So that's updating the state. So whenever the application state is updated, the store will inform anybody who is interested to know about any changes in the respective values. So this point number 4 is really where the reactivity comes in. So you set up your application to say, I'm interested in A, B, and C. I don't care about D and E. So whenever A, B, and C changes, you get some notification or you get informed, and then it will render itself. So again, these are the concepts. So concepts, a lot of concepts. Let's run some demo. All right. So I have a simple library application. Let's run it and then see how it looks like. So this is a simple library application. We can basically add some books. So you notice that when I click on add some books, it waits a little bit before that book comes out. So that's because when I click on add a book, I actually make a REST call to somewhere to grab some name, some random name, and then add it to my library. I can then log in as someone, Cat, Bob, and then let's say I log in as Bob, and then I select a couple of books to pinjam, and then I click here. Then it goes to them, and then I log in as Cat. I don't have any books. I click on this thing. Sorry, what am I doing? I add. So now Cat has this one book here. Bob has 2 books here, and I can just change around, right? So if I can even log out. So, but it still says that Bob has these 2 books, Cat has this, and my book, which is guest, has 0, and the total number of books is here. So I can continue to add more books. The pages are random, right? So this is a sample application. So how do we create an app like this? I can obviously still do, let's say, I can jump this one under here, and I select this one and I return a book. So example, all right, let's say this is my application. How do you create something like this using the concept that we have just learned, all right? Now, basically, again, concept, we think about a couple of things. We think about how we model the app. That means what kind of data or data structures we need to store. We think about what kind of actions the application will trigger. If you look at the library, the models is basically the books in the library, and we have people who's logged in, and for each of these guys, what books I have taken up, right? So that's how those are the models. Let's look at the models first. No, let's not. let's then think of, these are the, what I like to share is how to think about developing apps using state management, right? So think about what kind of actions your apps needs to trigger. In this example, we are basically borrowing books and returning books, adding books and removing books, and doing logins, right? So those are the actions. And we need to look at how we lay out the UI with data. We also need to figure out how to get data from the store, and also how to dispatch actions. And finally, how do we actually do the real processing? How does it work? And how does it fit nicely? Really, all these concepts that I talk about is pretty much each of this is a single file that you just describe everything in there. So the first one is how do you define a model? So pretty straightforward, right? So it's about defining our interface. I have a book, ID, title, pages, borrowers. I have a library state model. This is the only thing that I need to track to manage the entire application. I need to know who is currently logged in. I need to know the list of books that I have and who has checked out what. So that's the model. The actions. So how to think about actions? Actions are really because Angular is in TypeScript, everything is in TypeScript. So let's not talk about the pros and cons. It just is, right? So the way we define actions is that we create a class for every action. So for each of these actions, we define the type. So I have a login, logout, add book, remove books. Some of these actions are without payloads, but for example, if I were to remove books, I need to say what books. And as you can see here, it's really a string array, so I can give a number of books to return. So I can borrow books, and I say what books, again, is the array of string. When I return books, sorry, I was removing books. So return books is the same thing. I might have some errors. So the reason for add book not having any payload is because for this demo app, I am actually randomly generating data. So that's why. But really, the demo example that I've shown, these are the only actions that is involved, right? So we have, I have the model. I have all the actions that can happen in my app. And then how do we display the UI? This is literally how I display the UI. I say hi, and then I span, and then I say I have a username, and it's just an asynchronous data. It's just a reactive piece of data. This thing will change when it changes, right? So I have my book count, I have my library count, and library page count. And then when I'm listing the books, I list it like a collection. Remember, I was saying an observable is basically a stream of values. So I say for each of my book, display my book title, and it's an async book. That's it. Sorry, it's an async it's an async value. My book is a stream of asynchronous observable object. So that's what it is. And literally, this is what the HTML will look like. All right. And then the second last piece is that I have my, how do I then select? So over here, you can see I'm basically saying I want to display my books, my book count, and so on, right? In Angular, the way each component works is that I have a HTML page and I have a JavaScript or TypeScript file behind it. So how this particular component works is that when I'm displaying, I show all these async pipe, whatever, my books, and just display the values. Behind the scene, all I'm doing is I'm declaring variables that says what piece of data I want to select from the store. So I say I want to select the library state punya username, and that's it. I don't do anything else. I want to get the book count, how many books that constantly changes reactively. I say I want to select my book count, and then I say it is an observable number, and so on. Some of these things, as you can see here, some of the benefits that I kind of personally like about TypeScript is that I kind of know what I'm getting. In this case, I'm getting my books, and it's an array of books. So I know in my front end, I can do a loop, right? So as simple as that. So that's it. The rest, I think I'll skip. I think I'm like very over time, so I'll skip some of this. But the other one that useful to share here is when something happens, when someone clicks on something, all I'm doing is I mentioned we dispatch an action. So you call the store, you dispatch a login, passing the username. The username obviously is, I think I hard-coded in this case. When I return a book, I grab the list of selected options from my UI, and then again I dispatch an action that says I want to return books and these are my book IDs. End of story. So this is really all there is in my component, all right? And then I've demonstrated all the pieces except for the most important one, which is how do we process the business logic, right? So what NGXX provides is something called a state container class. It's basically a class that you annotate or you decorate it with a state. And then within there, you have two general things that you do. You describe how selectors work. When someone selects for a username, what do you give them? When someone selects for a username, you give them a current user. When someone selects, let's say, my book count, I take from my state and I calculate, or what I call a derived value. You calculate something and return the number of books to them. That's it. So all these things on its own is a very simple thing, right? So you select stuff, and then you describe or annotate or decorate actions. So when someone says action, I do a login action. What do you do? In actions, you basically do two things. One is you write reducers. Reducers are basically, again, a Redux concept where you mutate the state. So you can mutate the state by patching and then set the new username in there. Just update it. The value of one of the things that I find you can do with NGXS that you can't really do with, say, for example, NGRX for the Angular developers is that in this particular library, we combine a single action for both reducers and side effects, which is things that if you use Redux, you have to look for different concepts to combine them together. But in this case, instead of just reducing, I'm just returning an observable. And this observable basically will go out to a URL, do some stuff, and then create a new book, and then patch or update the state with the new book. That's it. And same for remove books. Everything is just some actions that manipulate the state. And how to make it work? You just register it into the Angular way, and then things just work. It's just a single line. And that's really what I've demonstrated is the gist of the business logic for the entire library applications. The rest of the stuff, everything is all reactive. You don't even have to do anything special to it. You notice I don't subscribe to observables and I don't do a lot of stuff. So, but the focus is that you must be clear about how to structure your app. So that's the idea. Some of these things there are a lot of bonus stuff that you can get from NGXX. You can get plugins, storage. So if you enable the storage plugin, you can actually turn the state that you are managing to be persistent. Meaning the next time you come in, you still like auto login or you maintain the state of the user. You can do all those kind of stuff. You can even have it's actually compatible with Redux DevTools, and it has a couple of other interesting plugins that you can take a look if you're interested. And in summary, right, so observables makes a very complex reactive operations manageable. It's not that it's the best or what, so use it when you have something complex. I think it will make your life easy. NGXX is, I think, is a very good state management solution for larger applications in Angular. And from my experience, it fits like a glove. So I really like it. So do give it a try. So that's all I have today. Thank you very much for having me here. Any questions?
One question.
Okay, yeah. Oh, no question, that's okay. Is it okay?
Cool. Alright, thanks, Casey.
Yep.
Definitely very eye-opening. Next we have Wick, and he will be talking about style components. Right, Wick?
Okay. Yeah. Okay, so we saved the best for the last.
So it's
okay.
a part 2 of the talk he gave last month. Yeah.
Sorry, wait. gonna start sharing again.
Join.
Present. Okay, so that's 917. Alright, cool. You can see everything. In the last talk, I started off with, oops, let me just go back to the beginning. Alright. I was speaking about style component and storybook. Now, these are two JavaScript libraries that allow us to create, it allows us to save world hunger. Alright. So, I'm gonna move on. I'm gonna take out the word React because I'll show you later why. This is me, I'm Vic. I am a tech lead at BAE Systems, and that's my contact details. I'm gonna breeze through because I wanna spend more time in the questions later. Now, let's talk about something we all have in common. When we're building big pieces of software, or even small pieces of software, we wanna share code, basically logic and UI. In the previous talk, you heard about presentational components and smart components. So I'm going to talk more about the presentational components today. We want to be able to achieve less duplication, redundancy, less code, less bugs. We want everything to be more consistent. We want to encapsulate the logic into the components, which is pretty much where the world is heading. And we want to share these components visually, not in a PDF, but actually like hosted somewhere visually. And we want to reap the benefits. Now, today, I'm just going to talk about two things that promote reusability, and I'm going to talk about encapsulation of presentational styles, and I'm going to talk about how to share these components. Now, let's just have a quick think about how we got here. CSS was implemented in sort of like 1996. This is 1994 when there was no CSS. We badly needed it. This is where we all started from, CSS. If any developer has been in the building web stuff for more than 5-6 years, you're pretty much going to follow a similar journey to this. But CSS wasn't enough. You need layouts, you need grids, you need to do so many things. So it becomes quite, you want variables. You don't want to code the same color everywhere all the time. So this is kind of the journey that, it's a rough journey that like many people might take. So you have CSS and you find the pitfalls of CSS. You want variables, you want mixins, so you have Sass. Then when you have Sass, people don't name things properly, and then you're like, no, we need BEM, right? This is the front end. Then when we have BEM, you'd be wondering why the style of one component is interfering with the style of another, because something to do with the class name of the great-grandparent. So we invented CSS modules to encapsulate styles. I'll come to style components later. Style components came out of necessity after we reached the limit of CSS with CSS modules. Now, when we're building software, like we can build it from scratch. However, there are component libraries out there, and I'm pretty sure you're used to most of these. So you have Bootstrap, which uses Sass. You have Angular Material, which uses Sass still. And you have Foundation that still uses Sass. Now, let's say you want to use React. Elemental UI is one of the more mature UI libraries in React because it was built for React. It was not like Bootstrap where it was taken and made to be made to work with React or other frameworks. So Elemental UI was one of the creators was Max Stoiber, and even that it needs less. So what this means is that when you start developing your JavaScript app in the world today, when you have JSX, when you're bringing HTML into your JavaScript, your styles still need an extra library, and that's kind of like it can be implemented, but why? He's the creator of Elemental UI, who proceeded to create style components. That's Max Stoiber. So when you wanted a button, you're actually getting what you're getting was a gorilla holding a button with an entire build toolchain. Now, we took Sass because we needed the features of variables, splitting your files into multiple, splitting your huge CSS file into multiple files. However, just like Babel is transpiling our JavaScript so that we can use JavaScript from 3-4 years later today, we have things like CSS Next that is compiling next generation CSS code to what the browser would understand today. Which means all those features there that CSS Next aims to support, in the future, your browser, if they implement the spec, they should support it. So we don't really, in the future, need to rely on Sass and less and things like that. That's a lot of features that you go to Sass for. CSS Grids is awesome, by the way. So, like, once you know all these things, you don't want to use things like Sass. So, I'm just gonna get to styling in React, but let's talk about styling in the component age, because we had 2 Angular talks before this. Now, this might be React code, but imagine it in any component framework. You're importing a CSS file. You're rendering the component, and you're adding a class name with the classes in that CSS file. Okay? Now, that's the first way to do it. The second is inline styling. Inline styling is supported by, I think, all the 3 major frameworks. So you have the div, you have the p, and then you have div style equals to, you give in the style as a JavaScript object. Notice the camel case and text align. So if you copy paste code or CSS anywhere, you need to do some refactoring if you paste it in here. Unnecessary. Now, CSS modules aim to solve a few of these problems. So it aimed to allow tight encapsulation. It still relied on importing an external style sheet. The devs still use Sass, Less, and PostCSS to build style, so you still needed that extra toolchain. And it was co-created by Glenn Mattern, and who was the co-creator of Style Components, with Max Stoiber, the guy in the picture a couple of slides before. CSS modules, I'm going to spend like 30 seconds on it. You have the H1, you have the CSS, that's the title. How do you style it? You import the style, and you send in the styles.title. It takes in, it transpiles the style into kind of like a CSS object that you access. What it gets translated to is a random class name there, and this gets added to your styles tag. Now this allows you to have components that are not affected by each other. However, the guy who built CSS modules, one of the guys, he called it Welcome to the Future, CSS Modules, Glenn Mattern, and he explained the problems with CSS. Beautiful article, I'll link it later, just read it. But Glenn Mattern and Max Stoiber ended up in a bar in Sydney. This is a true story, and they spoke about why CSS modules is still a limitation. And so they came out with something that I think it's the next step. So Style Components is basically built on the lessons learned from CSS modules. It doesn't need an external build toolset, and it conceptually tallies with the component age, as you'll see why. Plus, people just like it better. It's just much more fun to use. So, yeah. Now, we're going to talk about buttons today. Actually, we're just going to focus on a button. So, this is like a button making machine. So, you put in like a plastic sheet, and you press this thing down, and you get buttons. So, I think I'm in the wrong talk, sorry. Okay. Now, the button is like, it is one of the most primitive, or maybe the most primitive element of user interaction. So there are beautiful articles out there about how buttons evolved all through human evolution, and that is a big beautiful OK button. Buttons got better, even much more better. That's something that you see all over the web, and you're wondering why people don't spend some effort to change it. And so let's talk about the button component, or the button with a capital B in React. Sorry about the ES5. I was just like finding the best screenshots. So anyway, this is in all its glory a simple button component. And how do you manipulate the appearance? You have if else, and you add and remove classes for that button, and your classes are in some CSS file. So this, sorry about the dimness. So you have a button component in React, and they expect you to use a class name, and inside that class name you have btn, and that's like saying, hey, you're a button, and then, hi, remember you are actually a button, but now you're called btn, and then, oh, by the way, you're primary, so btn primary. Now, this code you'll find in the component that has the buttons, so the parent component. So basically, the parent component is telling the child, you're a button, but these are the extra stuff that you need to look like. So you're kind of like dressing the button on the way. Anyway, you get the idea. So that's an implementation detail. What if we could do away with that? Because we have props now. So we have button, and we get a prop called primary, and the button knows what to do. So how do we do this? So if we're using style components, you just need to do that, import style from style components. The next thing you do is const button, style.button, and inside there, oops, let me just go back. Oh. All right, if you can look at the dim part down here, it's just regular CSS. Now, the magic happens in here, which is just basic, it's just a template literal, and you're using JavaScript to detect. Does the props have a primary? If yes, the background color is white or pale violet red, and vice versa, like that. Okay, so that's what you get from that simple CSS. So we have a button. Now we want to share it. Now you created this awesome button, but you can save it as a HTML file and send it over in an email, or you can export it to a PDF, but that doesn't show how it works when you click on it, so it's not interactive. So then we come to style guides. Style guides, everyone needs them, and every organization needs them, the world needs them, and that's one of the Berkeley style guides, which explains, it has these colored annotations and what a button's supposed to look like, and that's a PDF file. But that was probably not enough. This is the Lonely Planet style guide, where they have different states of how the button can look side by side, and they have the HTML code that you can copy and paste into your code. Now, your aim is basically to build a component library, and you have it hosted somewhere, and it's visible to your UX team who gave you the UX in the beginning, so they can check your team, your project, your test and QA, so they can see whether the components built correctly in the first place. And if you're open source, you can put your style guide out to the world. So, roads where we're going, we don't need. So I'm going to show you like maybe one of the things we can aim for as we approach the future. So we have Storybook. Now Storybook was simply built out of necessity because everyone seemed to need it. When people use Storybook, my reaction was like, why didn't we have this before? Now what Storybook does is it takes your components and it gives you a left sidebar where you can choose these various components. And if you can see here, you have a button, which is the hello button. Right. Now, I'm just gonna take this one step further. Storybook has add-ons, where this is the knobs add-on, where on the right, you have the props. So you have background color orange. So when you click, basically you can select the background color and the color of the button will change. So you're checking how your component works in real time. Now, Storybook and style components, match made in heaven, but not just in the React world. I'm gonna do a quick demo later, and you can see why. Now, Storybook started off with React. Even on their main website, it says React. But if you go on their GitHub page, that's the various frameworks that they support. And John, yes, HTML web components are there, so you can play around with them, right? Well, it's an alpha. It's an alpha. Come on. All right, commit some code, dude. All right. So anyway, now this is even. Anyone using React Native? Anyone done React Native? Okay, so React Native has certain elements. Sorry? Yeah, right. So React Native has certain elements where it's not there in the HTML world, where you have view, text, image, and touchable. Touchable is a button. View is just a div in a way. Text is H1, H2, your typography, and image. Now, style components implemented that like within itself. So style components you can use in React Native and the same code. You don't need to write your CSS twice, which is what a lot of people were worried that they will be doing when they're using React Native. So truly universal React components. You have view style components as well. So style components is so cool that even like the main guys who coded style components, they have an official repo for view as well. Style elements, John. Now this is like so cool. This is like for web components, and they implemented the concept of style components even there. Now I'm just gonna go to a quick demo, and I'm just gonna. All right, cool. So 17:34. All right, cool. All right, so everyone's used Create React App. Okay, so it's basically the way you bootstrap React App now, and I've just bootstrapped a fresh React App. Now, I've added these three npm libraries. So I've added Storybook, style components, and a thing called knobs, which I'll show you what it does. I'm gonna save that, and okay. So this is the app.js file, which everyone starts off with. Now I've made what I've done is I've just added a p tag with 2 buttons, and I'm just gonna save the oops. Ooh, work. Oh. Okay, so I have 2 buttons there. Now these are regular HTML buttons. What I could do is I could go into the app.css, and I can go down there and I can start adding CSS. Yeah, but I don't want to do that because it's gonna go back in time. Oops. The screen share is making my laptop lag. Ooh. Okay. Now, I'm just going to change this to a button, like a button component with a capital B. In the React world, anything with a capital B is considered a component. So I'm just going to save that. Of course, we don't have that because we haven't created the button component yet. Now, as I showed you, like style components is very simple. If you want to create a simple button component, all you have to do is import the style package, create a button. That's an empty template literal, and you're good to go. And you have 2 buttons. However, and of course in there I can add some style. I can put like maybe border 2 pixels solid. I'm gonna go bad here, like red. Oops. Oh, so slow. Okay, so I have that, but I don't want that. So I've created a different button file, and I'm going to show you how that button looks. This is just a button.js file, and it's importing style components, it's exporting style.button, and I am taking in I'm checking whether the props has a primary prop, and I'm changing the background and the color based on that. And that's all the logic that is in here. Now, style components also accepts pseudo selectors right there, and it also accepts nesting. So you can go like, you can use a lot of features of Sass in there. Now, I've showed you the create React app, but let me show you Storybook. So I'm gonna go yarn run Storybook. Okay, so Storybook comes with its own little Webpack build, which you can customize. It's similar to the Create React app, where you can override it and you can make some changes. It's much more easier with Storybook than the Create React app. But yeah, so okay, we've started, and that's the default port 9009, and we have Storybook here. So I'm just gonna make everything bigger because it's okay. Now, in Storybook, we basically create stories for various components. Now, this component is basically nothing. This component is a button with some emojis. This is with props. Now, like, this is not like a PDF file or even a saved HTML file you're sending off. This is something that you probably want to host, or anybody can provision on their local machine, or host it somewhere in your local network, or even on GitHub. GitHub pages support Storybook. I'm gonna play around with how this button looks. So just now I added pseudo selectors for the disable style. I'm gonna click on disable. That's the disable style. I'm gonna make it a primary button. That's how the primary button looks. I can even play around with what the button says. So you can see how that button you've coded works in real time. Now, you also have nested styles where I basically I have a strong element inside the button, and my CSS is my style components is capable of styling that strong child element there. So that's basically where we are, and I hope you guys see a necessity in this and how awesome it is, and I hope you guys will start using it like as soon as you get home. So yeah, any questions?
Wait, how can you talk about evolution of CSS without touching Shadow DOM?
Well, that's the thing. If you
That is grandpa.
okay, no.
Okay.
We skipped a few things like post CSS and all that. It's not there, but yeah. Anyway. Okay. Yeah. But the second inline styles method I showed in React is using Shadow DOM. So.
Any question?
Oh, virtual DOM. Sorry.
Last question. Yeah.
So I'm just trying to think what I learned here. So the idea of Storybook is that you use some components, and then you look at them in Storybook, and then you just customize it how you want your app to look like, and then the components are those starting as apply to your app. Or
Well, what I showed you is the button, but like for example, like let's come back to. Okay, are we exporting the app component? So this is the app, the React app component. It's exporting that component. This is a component with other components inside, right? So I'm gonna just go to. Is that okay? So this is basically where I'm building the Storybook, and I'm just gonna go app. I'm just gonna. Okay, so I'm just gonna go import app.
To answer your question, basically there are two ways to look at what you wrote, right? You either go in the app, dig for it, or you just go to Storybook.
yeah.
Basically that answers.
Storybook is like a swagger for
Yeah.
Yeah, it's regular for you.
Isn't that what I was saying?
This is exactly what you were saying.
Yeah. I think, well,
Where can I find it?
But the trouble with all this stuff, I mean, I'm just sorry to kind of put it around to
No, please go ahead.
I see a lot of developers, or like the user experience people that I'm having to work with of late, they spend a lot of time messing around. I guess they use material UI as a template, and then they're spending time customizing material UI to give the app a particular look and feel. But the real issues with UX, which are not being solved in my opinion, is like, you know, the user experience, like what do people do with the app, where they go, and how they interact with the app. So sometimes I think it's like masturbating almost. It's like
Well, I have a slightly different opinion on this. So if you look at Storybook, right, I think the example that for the benefit of like presentation, using a button sort of like undermines what Storybook does, because from what I've seen, what people have done is that they create actual screens based on specific states of an actual application, not just a small component. So it's can be a very complicated.
But does it go through the flow?
So what you can do is you can create different use cases. You show each on the screen. So you click on different. I forgot the term that you use. Basically, stories or something like that.
Yeah.
Each of the story shows a different view of a different state of a screen. So you pretty much.
So this is the entire app screen. You've put that app component. It's inside Storybook. So you can create dumb components, inject dumb props. So you're not calling an API call or anything, so that the UX guys can come in and click on it and tell you that the click state of the button is 2 shades to you know.
I see that being a useful tool.
Yes, and you can actually there's a thing called links where you can link this find spoon button to another story, so it goes to you can go between stories and stuff like that.
But stories are just an app with a state, right? They're not like
There's
well, I guess that's fine.
there might not even be a state here.
Actually, I think
I was just thinking about like navigating between routes, but I guess
yeah.
One of the benefit of using things like Storybook is that again you have to think from. You remember what we mentioned about like stateless components versus the stateful components. All the stuff that we see in Storybook are all stateless components. So it's all screens without services, without stuff like that. But the properties are all configurable, right? So you just add as many stories as you want, as complicated as you want it, and then show a particular state. That's it. Then when buttons happens, like you said, you can route it to different stories and so on. So it's to help us prototype or look at screens.
Okay, great discussion. Thank you everyone. It's 9:45. I think we have to end this.
Thank you.
Yep, thanks Vic. Thanks to all the speakers for preparation. And I'll make sure to post out those video links so that more people can hear. More people who aren't here can hear what you said. So yep, thanks for coming and thanks for staying throughout the whole session. Good night, guys.